China, but some China dialect completely different.
Yeah.
Like some part of Cantonese,
Yes,
it's kind of old.
Okay, today is Saturday, May the 6th, 2023. It's 11:50 a.m. Arizona time. This is our Saturday session at Desert Blockchain Camp. We're talking with Austin Wright about his submission to the IETF on modification of the patch method for HTTP. And this is just kind of a general chat.
That was my first time traveling outside of North America, actually.
Oh, really?
Yeah, my trip last month.
So how many go to the conference?
I think there were about 1,000 attendees total, but most of the meetings didn't exceed 100 people. But it was pretty small. Or it felt pretty small. Yeah. I'll show some of the photos later.
Do you want a HDMI connection? You can use this.
I'm not. No, if I need to
me
present something, I'll
invite for the
You want to get on the Zoom?
no. I mean, I could. Well, yeah. I mean, if you'd like, you can text me the link. I don't need to join right now, but I don't have anything to show.
All right.
So, yeah. So, the byte range patch. Essentially, I was thinking how this got started. I was building out ideas for how to do and how to build out APIs around like long-running operations and making large uploads, and how to resume requests that have failed due to network connection errors and things like that. And a lot of these have implications in peer-to-peer communications, because networks change and your upload might get disconnected and things like that, which I'll talk about, or I already talked about it a little bit earlier. And so this is sort of the building block for a lot of this. The quintessential application is you have a very large file, like a terabyte, and you want to upload it in gigabyte chunks. And so you say, here's the first gigabyte out of 1 terabyte file. Here's the second gigabyte out of 1 terabyte file. And then you specify, here's the address I want to write to. Here's how long it's going to be. Here's how long the file is going to be overall. And then you specify the data. So that's what the syntax looks like right there. You say I want to write, or this is you say I'm specifying the contents of a file, bytes 2 through 5 out of a 12-byte long file. And then below that, you put a blank line. And then after the blank line, that just starts the actual contents that you're writing. So you say I want to write CDEF starting at byte 2 and ending at byte 5. And that's all it does. Yeah. And then if you make this with a patch request, a patch is a fairly new method. I think it's a few years old now, where it just says, I want to make this change to a resource. I want to change this resource according to the provided instructions. So there's all different types of patch formats. You can, the quintessential patch format is at line 5, remove this line, replace it with this line. This is a similar thing, but just for bytes. Replace these bytes 2 through 5 with these bytes. There's other patches as well. You can say, I want to replace this property in the JSON file with this value. Or you can write to a JSON file that way. You can say, update the title key with this string. There's all different types of patch formats. And so you can use this byte range. You can send it with the patch method, and it'll just write at that position in the file. sometimes like you just want to replace a few bytes in the file, like an audio file, you want to append to something, and you can use this patch file format for that. Yeah. So implications for blockchain, I'm not sure, but they're, like I discussed, you can potentially use a lot of these technologies in peer-to-peer protocols. I think HTTP is very well suited for peer-to-peer communications. Like if you want to just talk at a computer and say, hey, tell me information about this, and that computer can respond with information about it, and then it can also send back a query back to you as well. So you can say, like two computers can talk HTTP or make HTTP requests at each other, and then they can fill those requests and send information back. So, and also the fact that HTTP, you can use complete URIs. You don't run into like addressing problems and namespacing problems.
What about security though? I mean, you're just sending what's the word, not packets, you're sending packets, right? So
Yeah.
can they be intercepted, obviously, right? Probably.
Yeah, I mean, that's not, the security is handled by other elements of the protocol. So you can use TLS,
Okay.
or you can use DTLS,
Okay.
or things like that. And then and if you're using TLS, you can even say, you can use encryption, but public key certificates to authenticate
Okay.
users.
So this is basically neutral as to the methodology for sending, it just doesn't.
Yes.
And it's stateless.
Yeah,
So
Meaning it doesn't have dependencies.
Well, it means that the server doesn't have to know the state of the client.
So it always updates real time with.
yeah.
whatever
The
it
message
gets.
always means the same thing, regardless of the messages that were sent before it.
So regardless of blockchain or whatever, just you can just communicate you and I, the node, right? You're the node, one node, another node on the internet. We can just.
Everybody will receive
Yeah,
the same information at the
exchange,
same time.
Yeah, information.
All peers that are tuned into that.
And me, between me, me, whatever, right? So regardless, it has nothing, you do not need the blockchain. You can use it in a.
Well,
trivial,
you don't need the blockchain, but I think there's some interesting applications that
Yeah.
come up when
Yeah.
you've got a decentralized source of truth.
Yeah. So the working group
agreement.
I'm submitting this to is called the HTTP APIs Working Group, and the APIs.
It's on
working
the
group, yeah.
paper.
Okay.
So they're sort of a companion to the HTTP Working Group, but the HTTP Working Group is focused on developing HTTP as a protocol,
Right.
and the
So
APIs
this-
Working Group is more focused on extensions to HTTP that are more likely to be used by embedded devices
Yes,
and things like that,
yeah, right.
that are and that are helpful to developing APIs.
Right.
So there's another there's another protocol or extension. It might actually be in the HTTP Working Group, I'm not sure, called the query method. And that's also interesting because you can, it's safe like GET, so it doesn't make a modification on the server, but you can upload a request body like POST and get a response back from the server. So like if you're performing a computation, you can make a query request to the server and it'll process that upload that you made, and then it'll send back a response based on that query. But unlike POST, it's not asking the server to make a change to the server. It's just asking to process some information and provide a response. So you can remake that request if you have to. Like if there's a network interruption, you can remake that request safely, and that's not going to pose a problem. Unlike POST, where you can't assume you can just remake the request without side effects and causing problems. Yeah. If you had to, if your post request gets interrupted and you're making a credit card transaction, you can't remake that post request because you might get a second credit card transaction. You don't know, but query avoids that. You know that query means that it's not going to. The server isn't supposed to do anything that's going to cause trouble if you remade it accidentally. So that's another potentially interesting thing. It's designed for like database queries. You could send an entire block of SQL or some query like that to a server. There's a few other protocol elements that are interesting or have interesting peer-to-peer applications as well. What else were we on? I was mentioning you could use.
And you were talking about this in Japan at the IETF. Why were they interested in having you join them regarding this patch proposal? What kind of feedback did you get from them? And what were their, did they discuss any use cases?
Yeah, I presented most of the use cases that are interesting. And I think they understood all the use cases. I mean,
how many people were you talking to?
At the meeting, I spoke for like 20 minutes at this working group. I think there were a few dozen, maybe 50, like between 30 and 50 people. And then I spoke briefly at HTTP working group, which might have been 100, 150. I just said, hey, we're working on this in HTTP APIs. It might implicate HTTP a little bit for various reasons. So go check it out. The questions I got were very supportive and just general questions like, does this support multi-byte characters? Yes. Does it? What are the security implications? Yeah, there are some security implications.
And you addressed some of that in your write-up.
Like I didn't have to modify the behavior of the spec, but I did clarify some things.
Call it an internet draft?
Yeah.
Or is this a?
Yeah, so.
A memo?
Internet draft.
A memo?
Internet draft is just the terminology for specifications that haven't been adopted yet.
Okay.
But they're just proposals.
But you would refer to the document as a memo? Status of this memo? I'm just fishing around for what do I call this?
Internet draft. Is the IETF terminology. So it's a memo in an informal sense, like it's just,
So are you the only one who just present this topic? What about the other presenters topic?
I'm the only author so far. When I submit it, it'll get picked up by the working group, and like other people suggest changes, and the working group will together figure out how to merge those in or consider those. We also, at that meeting, we also considered other specifications as well, like we talked about existing specifications and how to do we talked about another media type called the problem media types, which is a standard way of conveying that there was a problem making a request in a machine readable fashion. So if you get a 400 or a 500 or something like that in response to a server, it can send back a JSON file detailing out some of the reasons that the request went wrong, rather than just spitting back an opaque error code. And there's a couple of other specifications that were adopted at that meeting as well.
So you mentioned query method also is also one of the.
Yeah, that's one that's in the working group, I think.
But you didn't write that.
So it's different than working group. You went to just the HTTP API API working group, so for the.
I forget,
query method, it's
I forget which one the query method is, and it doesn't really matter. It has pretty broad support, and it'll hopefully get approved one of these days. It's been sitting around for a few months. I don't know if anyone's worked on it lately. Yeah,
Also someone gave a.
That's a big deal.
How to use it.
So that's a big deal because querying in a decentralized, like on DHTs, is a huge problem.
yeah. So it's a little bit of a different topic, but I thought if you want to look up a value on a DHT, you can use HTTP to do this. You just say you use some sort of routing table to figure out which is the most likely computer that's going to know how to answer this query. And then you send it to them. But you say, you can make the request with a full HTTP URI and the request line. Or it doesn't even have to be an HTTP :URI. It can be something else entirely. It can be like a UUID or something. So if you want to have a distributed like key value database that maps like UUIDs to values or hashes or something, there's also like a digest URI. So it identifies resources that have a given hash. So you can say, I want to download the document with this SHA-256 identifier. And there's going to be URI associated with that, like hash SHA-256, ABCD, whatever. You make a guess as to which computer on the network is most likely to know the value of that. And then you open an HTTP query or request to that computer and you say, get this resource with the digest URI. And then if it knows that, and if it has that on its local storage, it just replies to that. And if it doesn't, it can say, it can use like a 303 redirect or something and say, I don't have that, but try this other server.
Right, right. Well, that's the way a DHT works now. But it's very inefficient because you've got to do all this querying to potentially millions or billions of nodes, and that can be very slow and very cumbersome. With content addressing, you have a higher degree of security because you've got to hash the content that you want. But if you don't have that, then you got all kinds of trust and security issues because anybody could send you anything that could be malicious. And that's a big, big problem. So
this is time consuming.
It's time consuming
and secure.
Right.
No.
Right. And it's very, very inefficient. And but if you had a query method that could work over HTTP to find the resource, and above and beyond that, if it didn't have to be, if you didn't have to know the hash of it, and you had some sort of secure or some sort of trust factor, that would be really, really valuable.
So what about if there is, there's centralized internet, or decentralized internet, like IETF, and maybe like others, you can put your query distributed centralized.
Yeah. Well, I mean,
the database and other, we can create, decentralized internet.
Yeah, well, I mean,
information.
yeah, these are all, in my view, big issues in terms of speed, efficiency, trust, identity. But what I'm hearing out of what you've written up is that at the outset of the media creation, there's a defined location or global location or address that you create. Because you say, okay, this is going to be written to bytes 2 through 5 of some sort of context. And that's part of the, it's almost like part of the media, correct? So in other words,
yeah, I mean, it's
so-
essentially the same thing as just how files work on a file system.
right, but you're at the outset of the media creation, you're defining what I would call as a universal identifier and or location for that media stream that's going to be created. And then as long as everybody knows that address is going to sort of be immutable for that media that anybody can store. Yes or no? Or am I wrong?
I'm not following.
So in other words, we're going to record this Zoom session. And let's say it's going to be 4 bytes long. Let's say maybe it's instead of 4 bytes, it's 4 terabytes. So
Really good compression algorithm.
that's right. And what was your example on this? Let's try to keep your example. And we don't have to go into this much detail on this thing, but I'm just trying to get my arms around it. Okay, so CD EF. So bytes 2 through 5 of 12. That's C, D, F. So this is going, and this is, you know, we got some sort of front end identifier. And it could be a hash, could be just a uniform number, whatever. As long as you get this, and then you create your zoo. So you do this first, and this is HTTP patch. It's stateless, but the key part is that this is created first. Is that correct? Before the media content is generated? Am I getting this right?
Well, created like.
So in other words, before we start the Zoom, it's going to be up to 4 terabytes. Your specification identifies that this patch is going to happen in bytes
Yeah, it's
2 through 5.
like those are the bytes we're going to change.
Those are the bytes we're going to change. We're going to change those bytes with this new media thing that has yet to be created.
Well, like it's just the data we're writing there. It can be anything.
Right. But I'm using a media as an example.
I would say it
Yeah,
sounds like it has to already exist.
I don't think it has to exist.
You can use patch to create resources. So like,
Patch is just the format, you call it patch, right?
Yeah.
To send.
Patch is like a
upload,
put, it sounds like.
To upload,
It-
to communicate, it's information, right? Just in images.
yeah, patch is a little more flexible than put, but it can do all of the same things mostly. Just instead of uploading the entire new resource all at once, you're specifying only the parts that change.
Hmm.
With
Patch.
Yeah, or you're specifying instructions on how to create a new resource. So you can use a patch to say create a file that's 1,000,000 bytes long of only zeros or something like that. Or you can say write you could potentially, I don't know. Here's an interesting idea. You could use a patch to upload a script and say server follow this script on how to write up this file. Like you upload a function in JavaScript or something, and the return value of that function is the contents of the file that you want to create. I don't know. But for the byte range patch, like it's very uninteresting. It's just the same thing as I want to write, like if you have like an audio file and you want to append data to the end of it because you have a recording that's in progress. Maybe that's what you're talking about. Like if I have a recording that I'm making in real time, and I want to say a portion of it has already been uploaded, but the recording is still ongoing, so I want to say continue appending to this recording and append at byte 5,000. And here's the rest of the audio stream that we're recording right now. You can do something like that. So instead of having to, yeah.
And then once the recording ends, this, I'll call it a location for lack of a better word, bytes 2 through 5.
The address in the file.
Address, whatever.
The bytes also.
That becomes, that's how people would look it up if they wanted that patch.
That's a resource, right? The part of the resource, the portion of it.
Yeah.
Right?
Like you could make a range request and get back those same bytes. You could say get, and then whatever file that you're looking to get, and then you can say range bytes 2 through 5. And then if the server understands the range header, it will return only bytes 2 through 5 instead of the entire file.
Mm-hmm.
Again, like this is mostly interesting if you're talking about updating or changing specific file formats. Like if you have an MP3 file and you only want, the second hour from within it or something like that. Or if you want to upload only the third hour because the first 2 hours are already uploaded. That's like sort of what this is for. And that, I don't know how interesting that is for like blockchain or peer-to-peer things, but
So my understanding, I don't know what is right and not. So is that using this, you can just upload, send out the information, in a speed, whatever as you like. Right? Is it, it's a flexible. So the portion of the patch, like you said, 2 to 5, or you can 2 or 3 or 4, 5. So it's a flexible. You can just it's up to you how fast you want it to go.
Yeah, like the alternative to this, previously you might have, or actually this is how media is done right now. You might have to split the upload into multiple different files.
Yeah.
And then you have to get each of those files in sequence and read like.
Yeah.
Like
that's how stream.
Yeah, like HTTP live streaming and things. Yeah, you have to break up the files into chunks, and then each of those chunks is a different file. And you have to make a different HTTP request for each of those files.
Yeah.
And it's a little bit inefficient and kind of complicated. And this, with like range requests and with byte range patch, you can not only read a very large file, but you can also make small writes to a very large file.
You mean that you do not need the head of that, the head information? So I think you mentioned that you maybe do not need head information, you just send it, but you also need to specify, the each portion will identify each
Well,
portion, right?
I think this, so what's coming up for me, are you familiar with conflict-free replicated data types,
Yeah.
CRDTs? This seems like be really powerful with CRDTs.
It's the same class of, it's the same class of writes, like,
Because the problem with CRDTs is you've got changes coming in from all sorts of different places, and then you've got to put them in some sort of order. And this seems like you've got more flexibility with the order, that the eventual consistency. See what I'm saying?
yeah. It depends on the like specific application that we're talking about, I think. Like, well, so yeah, like I guess this is like a conflict-free replicated, like
Yeah.
multiple clients can make the same request and it's not going to cause a problem. Like you can make the request the first time and it'll make it right. And then if another client makes the same right, it's not going to change the server further.
Yeah, but if you make a change, or one of the, let's say, participants makes a change, but then you find out that somebody had made a change before that in time, it just hadn't gotten there. This would allow to add that prior, data or input. You see what I'm saying? It's more flexible.
This could potentially be a part of a solution like that. Like this isn't conflict-free in the sense that you could change the order that you're writing in and get the same result. Like if two clients wrote different values to the same offset, the last one would win. Like the order matters. And I think the point of the conflict-free replicated data types is that the order doesn't matter. So you could have like you could have one client saying, Alice's bought a ticket, and then you could have a different client saying Bob bought a ticket. And then regardless of which order they submitted those requests, the state, the same data will be reflected on the server eventually.
Well, let's.
But you could.
I think the bottom line, Austin, is this is really, really interesting. And I think has application or potential applications that could be very interesting. I don't know for sure, but I would say this is more than just a casual or trivial thing in different contexts.
Yeah. And certainly I see a lot of potential for it, but like mostly in contexts like I'm uploading a huge file to AWS and I don't want to lose it if the connection gets interrupted.
Yeah.
Or like web browsers could build in support for this so that you're less likely to lose an upload if you're uploading to a server. Like that sort of thing. But there's I'd like to see what other like a specific other application Right.
Well, I think it's really interesting. I think it'd be really fun to play with. Have you stood up a prototype of this or played with it?
I've been intending to make one. I have a little bit of I have something on GitHub, but it doesn't implement some of the changes I have here.
So you haven't actually stood up a working demonstration of this.
I should.
And that's fine if you haven't. I'm just trying to figure out where you're at with this thing. And that could be done just with some simple HTTP servers, right?
Yeah.
So you could do,
I have a proof of concept for something similar to this in Node.js. So
in Node.js or at the Node.js meetup?
like it's written with Node.
With Node, okay, cool.
Really? Would not?
Node.js, I mean, but I don't,
It's on your GitHub?
yeah.
Okay.
Would not?
So he's got a write up in Node.js.
Or in JavaScript.
In JavaScript that would be the start of standing up a prototype to start to play with this. Is that correct?
Yeah.
Okay. Well, I'm interested in playing with it. I mean, like I said, I'm still in the beginning stages of getting my arms around HTTP and all the intricacies of it, combined with HTML. But it sounds like, we could stand up a couple Raspberry Pis, or you could even do this on one Raspberry Pi or any computer, basically,
Yeah.
with a couple HTTP servers.
I think the interesting thing to look at would be like what I was talking about, like setting up a DHT of HTTP servers, and you can make a request to the cluster.
You should go to DWebCamp.
Yeah,
You
when
thought
is
about
that?
that? June 21st through the 25th? Because there's a ton of Filecoin people that are going to be there. They're really, you could get funded for this, for sure. And Juan Benet should be there, the founder of Protocol Labs. There's going to be a ton of DHT experts, probably Jeremy Johnson. And I have requested that the organizers of DWebCamp reach out to the Stellar Network and David Mazieres, who invented Kademlia, who's at Stanford. There's a chance, well, I don't know if he's going to make it or not, but I mean, those are the people that created DHTs.
Mm-hmm.
So anyway, but if you're messing around with querying DHTs in a more efficient way, or creating some sort of construct where you can,
Or a more universal and standard way.
yeah,
At least.
That's
I don't know if it
huge.
does anything like functionally new, but
well, even the slightest improvement.
yeah, like the
Makes a
idea
huge
that you can
difference to these
query a DHT using a normal HTTP request and not need so you can now query a DHT from your web browser.
I haven't heard of that at all.
Yeah.
And I'm not a DHT expert, but nobody's talking about HTTP in the context of DHTs, as far as I know,
Yeah.
that I've heard. But that would be.
Now, I mean, to be clear, this idea doesn't implicate byte range patch at all, unless you're talking about really huge files. Like, so if you wanted to store like a terabyte file on HTTP DHT, then you'd have to figure out, well, we'd have to figure out how to split it into chunks, and then reassemble those chunks later, and then maybe
Well, that's what they do.
Maybe you'd use like range queries and patches to upload them and retrieve those chunks or something. But
that's what they do. with their, I think it's IPLD. That's exactly what they do. So Internet Protocol linked data, they're chunking content, and then they've got a Merkle DAG that figures out how do those chunks fit together. And then that's all tied to a DHT.
Mhm.
So, you know, the worst that could happen is they look at it and say, hey, we already know this, or it doesn't work, or whatever. Best that could happen is they say, Mr. Wright, we'd like to give you 500,000 to do some research on this, because they've got that kind of money. And if you,
Mhm.
I don't know if you've looked at Protocol Labs at all, but this is exactly what they're trying to fund in terms of research and so forth.
What's your
And-
GitHub
and-
address? Oh, sorry.
All right. AWW-RIDHD.
And Marta Belcher, who's the chairperson of the Filecoin Foundation, is already signed up for DWebCamp.
When is it?
June 21st
Yeah,
through the 25th.
deadline to.
But they're still open. Registration.
Yeah, by the way, I was thinking like how you're planning to get over there.
I'm gonna be driving, but I'm planning to do a little stop in LA on the 19th. So I'm driving to LA, probably hopefully stay with a friend. And then I'm going to San Francisco on the 20th, spend the night there, and then everybody goes up to the Redwoods the 21st.
Because also for me, I don't know how is it driving, is it flying, or the best way, but it's really far and all.
Well, they've got buses and things like that to get from like the Internet Archive up to Mendocino or Camp Navarro. So, anyway, so I'm gonna shut off this recording. Okay. Is there anything else you want to say before I shut off the recording?
Thank you for presenting for us. It's a cool project.
Come back, few days ago.
So that's the end of the recording. We're gonna chat a little bit more, but thank you for tuning in.